Alright, so now we're on Chapter 7, Lesson 9, and the Common Core State Standard is apply and extend previous understandings of multiplication and division to multiply and divide fractions. If you look at this worksheet, the first instruction says find the product, write the product in simplest form. The next part says use the distributive property to find the product. I'm going to show you 3 different ways to kind of go about this process. Now, these ones, you can kind of use whatever method you want when it says find the product. They'll typically look for methods 1 and 2, whereas when it's the distributive property, you have to do it that way. So I'm going to break down the 3 different methods. And unless they specifically say you have to use the distributive property, you kind of have a choice at which way you want to go. None of these will be diagrams. They're all going to be some type of mathematical equation, formula, or however you want to state it, procedure. So I'm going to take number 1, and even though they kind of break it down for you, I'm going to explain this. So the first one is 1 2/3 times 4 2/5. Now the first way is by changing things to improper fractions. And so before we can get there, let me explain a couple of vocab terms. The first one is a mixed number. A mixed number is kind of what it sounds like. It's mixed. And what it's mixed with is like a whole number and a fraction. So it makes this a mixed number is that there's a whole number and a fraction. It's mixed together. The other term I'm going to be using a lot today is improper fraction. Now, an improper fraction is when the numerator is bigger than the denominator. So, the numbers 6, 7, the numerator is 6, and 6 is less than 7. So 6/7 is not an improper fraction. Does that make sense? Now let's look at the number 8/7. 8/7, the numerator, the top number, the 8, is bigger than 7. Therefore, it is an improper fraction. And what they kind of mean by improper is the fact that when the numerator is bigger than the denominator, this number is more than 1. The reason being is you have 7 pieces total here, and then like in this diagram, 3, 4, 5, 6, and you have all 7 of them plus an 8th piece over here. So you have 7 pieces and an 8th piece. So every improper fraction is when the numerator is bigger than the denominator and you have all of those pieces plus some extra. If we want to change from mixed number to improper fraction, we can always draw it out if we want to. Like these are 2 wholes, 1 whole, 2 whole, and then a third. So if these were all split into thirds, you would have 1, 2, 3, 3/3, 1, 2, 3, 3/3, and then 1. So altogether you'd have 3, 6, 7/3. A faster way to do that is instead of always drawing it out, if you notice, this is your whole number, and this is how many pieces you're going to have. 3 plus 3. So this number is being repeated this many times. The number 3, your denominator, it's how many slices they are. That is what's being repeated. And this is how many times you're repeating it completely. You have completely 3 out of 3. You have completely another 3 out of 3. So you could actually just multiply these 2 numbers, the 3 and the 2. And the reason why you could multiply them is you could see here it's repeatedly adding 3 and 3. Now what you're going to do with this extra one after you do the 3 times 2 is you're going to add that because you don't have a complete third one here. You have just a mixed number, a part of it. So you're going to do 3 times 2 is 6 plus 1 is 7. 7/3. So we're going to be doing a lot of mixed numbers to improper fractions. And the way that we're going to do it is we're going to multiply the denominator, which is how many pieces you have, by the whole number, which is how many times you're repeating that denominator, and then adding it to what you have extra. So multiply, add. And as you can see, the piece size doesn't change, so therefore the 3 doesn't change. We're adding 3 plus 3 plus 1. That being said, let's go back to over here. This leads us to step number 1. Step number 1 is changing these mixed numbers into improper fractions. Currently they're mixed numbers because they're mixed with a whole number and a fraction, and we're going to change them into improper. Remember, we're going to do 3 times 1 plus 2. So we're going to do 3 times 1, which is 3, plus 2, which is 5 over 3. Now just for clarification, I'm going to draw that out. 1 whole and then some. The denominator is 3. You have 1 whole, 3 out of 3, and then 2 extra. And altogether, 3 plus 2, 1, 2, 3, 4, 5, is 5 out of 3. And we're going to multiply this mixed number, which is the same as this improper fraction, these two are the same, by this one. And again, we're going to change the mixed number into an improper fraction. So what are we going to do first? We're going to take the 5 and we're going to multiply it by the 4. Then we're going to take the 4 and add it to the 2. The reason why, the denominators, what we're repeating, we're going to draw a person to get 5 pieces. Oh man, we're going to repeat it 4 times? Holy moly, this is a lot to draw. Now you want to make sure that your drawings are a little bit nicer. It's a little hard to hold the camera and to draw at the same time. But we have our pieces split into 5. 1, 2, 3, 4, 5 for all of these. Then we're going to have 4 complete ones. 1, 2, 3, 4, 5. 5 out of 5. 1, 2, 3, 4, 5. 5 out of 5. 1, 2, 3, 4, 5. 5 out of 5. 1, 2, 3, 4, 5. 5 out of 5. Now we have 4 whole 5 out of 5s. 1, 2, 3, 4. Then we have 2 extra here. So what we have here is 5 plus 5 plus 5 plus 5. And like we learned from the last lesson, it's repeat addition. 5 is being repeated 4 times. 5, 10, 15, 20. So we could just do 5 times 4 plus these extra 2. 5 times 4 is 20, plus 2 is 22 over 5. So as you do this, you don't have to draw these pictures out, okay? You don't have to draw this out. I am just doing it as an example of why you're able to do 3 times 1 plus 2, or 5 times 4 plus 2. Okay, I want you to build that conceptual understanding. That is step 1. Step 2 is you can multiply. When it comes to multiplication, the denominators you don't care about. You multiply the numerator by the numerator and the denominator by the denominator with multiplication. You do not have to worry about them being the same. So you could do 22 times 5. If you can't do 22 times 5 in your head, you could do it out here. 22 times 5. 5 times 2 is 10. 5 times 2 is 10, plus 1 is 11. 110 over 3 times 5. 3 times 5 is 15. 15. Now don't forget, the directions did say in simplest form. So you have to change any improper fraction if the numerator is bigger than the denominator to a mixed number, and you also have to reduce. So the first step I'm going to do is divide. The 110 goes inside the house because it's the numerator. And then the 15 goes outside. If you don't memorize your 15s, you could do them on the side. But for now, 15, buddy, 15 times what number gets closer or equal to 1? Nothing, that's way too small. 15 times 0 is 0. Bring down the 1. 15 times what number gets close to 11? Well, 15 times 1 is already 15, and that's too much. So again, it's 0. And now you bring down the last 0. Now you're asking yourself, buddy, 15 times what number gets closer or equal to 110 without going over? If you don't know, just try multiplying some numbers by 15. Let's try 15 times 5. 5 times 5 is 25. 2. 5 times 1 is 5, plus 2 is 7. 75 is not too close to 110, so we could probably try a higher number. Let's try the number 15 times 7. 7 times 5 is 35. 5, carry the 3. 7 times 1 is 7, plus 3 is 10. Ooh, 105, that's getting closer. Just in case, let's try 15 times 8. We'll do it over here. 5 times 8 is 40. Regroup the 4. 8 times 1 is 8, plus 4 is 12. 120, that's a little too high. So between 15 times 7 is 105 and 15 times 8 is 120. We don't want to go over 110. We're going to use the 15 times 7. 15 times 7 is 105. Then when we subtract, we get 5. What do we do with that remainder? Because we're not working with decimals, you don't have to put a decimal 0 and continue. The remainder becomes your numerator, and your denominator is the same, the outside number 15. So our answer right now is 7 and 5 over 15. Are we completely done? No. If there's a number that could go both into 5 and 15, dividing and not having any remainders, in other words, having a whole number, then you could do it. You could divide by 5 over 5. 5 divided by 5 is going to be a whole number, 1. 15 divided by 5 is going to be a whole number, 3. So our final answer is 7 is our whole number, 5 divided by 5 is 1, and 15 divided by 5 is 3. So our final answer is 7 1/3. Let's go back to the way beginning. The question was asking 1 2/3 times 4 2/5. We changed them into improper fractions by multiplying the denominator and the whole number, adding the numerator, multiplying the denominator and the whole number, adding the numerator, and the denominator stayed the same. When we multiply, you do not have to worry about the same denominators. You just multiply the tops and the bottoms. And then from there, we put the numerator inside of the house, and then we divide, and then we simplify. If you need to, feel free to rewind anything, or you could look at way number 2. Way number 2 is going to look very similar to strategy number 1. And I'm going to put them right next to each other so you can see the difference. We're going to start with the same problem. 1, I think I might need new lead. 1 2/3 times 4 2/5. The first step is going to be exactly the same. You're going to change them into improper fraction, and this time I'm not going to draw the pictures out because we've already done it before, so you could rewind and see that. But we're going to do 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5, and our denominator stays the same. Here, 5 times 4 is 20, plus 2 is 22 over 5. If you check from above, the first step is exactly the same. Change the mixed number into an improper fraction. Step number 2 makes your life a lot easier. Before multiplying the tops and the bottoms, what you could do is, instead of simplifying at the end, simplify at the beginning. take your numerator and you're going to compare it to the denominators. So here are your two denominators. And you're going to ask yourself, is there any number that you could divide by both 5 and 3? No, you can't, and be able to get a whole number. But here, the 5 and the 5, you can. 5 divided by 5 will be 1. 5 divided by 5 will be 1. So if you do 5 divided by 5 and 5 divided by 5, this changes to 1, this changes to 1. And you have to make sure that you're matching up the same number, dividing by 5, dividing by 5, and you have to make sure you're matching the top with one of the bottoms, any one of them. Look, instead of doing at the end, dividing by 5, dividing by 5, you're doing it at the way beginning so that you save yourself from having to work with huge numbers. Then you look at the next one. You have 22. The numbers that you have left, 3 and 1, can you divide any number into both 22 and 3? No. So we're going to start multiplying everything out. 1 times 22 is 22. And 3 times 1 is 3. Therefore, 22 divided by 3, because this is going to be a mixed number. 22 is larger than 3. It's going to be more than 1. 7 times 3 is 21. And you have 1 left over. This is your numerator. That is your denominator. Your final answer is 7 1/3. Both answers you get is 7 1/3. Both times you're going to divide by 5 over 5. You're just doing it at different steps. This way some people like, because all you do is multiply the tops and the bottoms, and then you simplify at the end. Other people like to simplify beforehand, and then that way you don't have to work with such big numbers. Choose which method you want to use, and I'm going to show you the last method. The last method is the distributive property, which no matter what you're going to have to do in the second part, once you get to numbers 9, 10, and 11, this is the step that you're going to have to take, whether you want to or not. Sorry. Let's see, I accidentally... No, anyway. So, the last one is 1 2/3 times 4 2/5. And the way that you're going to do this is exactly like the area model, except you're not going to draw the picture off. So this is exactly yesterday's lesson when we did 1 2/3. We definitely need a new 1 2/3. And then we took 4 2/5, and then we multiplied each section. We're going to do the same thing for this, except we're not going to draw the picture unless you really want to. So the distributive property, you could either draw the picture and solve it that way, because this is the distributive property, or I'm going to show you how to do it with just numbers. 1 2/3 is the same as saying 1 plus 2/3. 1 plus 2/3. That is the same thing. 1 plus 2/3, 1 2/3. Times 4 2/5 is the same as 4 plus 2/5. 4 plus 2/5. And then for our equation, all you're going to do is take this number and multiply it by that number. 1 times 4. You're going to take this number, and you're going to multiply it by this number. Adding 1 times 2/5. And look at how that's what we would have done here. 1 times 4, 1 times 4, plus 1 times 2/5, plus 1 times 2/5. Now, what you're doing is you're taking this first number and you're multiplying it by everything on this side, because it's telling you to multiply. You take this number and multiply it by this first number. Then you add this number multiplied by this number. And it's exactly what you would have done here. You would have done 1 times 4, then you would have done 1 times 2/5, and then added those two answers. Now don't forget, you have that bottom row too. That bottom row is this one right here. Then you're going to take your second one and multiply it by the first number. So you're going to take 2/3 and multiply it by 4. And then you're going to take this number and you're going to multiply it by the second number. 2/3 times the 2/5. 2/3 times the 4 and 2/3 times the 2/5. Remember, you add 1, 2, 3, 4 answers. 1, 2, 3, 4 answers. Now, I'm not going to actually solve this part for you for this exact equation, but I will do it for the next one. I'm just showing you how to lay this out. The reason why is specifically more so due to time, because I know that these have been running a little bit long. So these are the three methods. You can either choose to change them to an improper fraction, multiply, then simplify. You could choose to change them into an improper fraction, simplify, and then find the answer, and then multiply. Or you could use the area model. Now I'm going to show you and demo the distributive property. The distributive property and the area model are the same thing. The area model is the picture, the distributive property is just the equation. In the next problem, and then after that, I'm going to help you with the word problem and then wrap it up. Alright, so let's go on to the next problem. Okay, now we're really going to hone in and focus on the distributive property method. Now, the distributive property method is very similar to the area model that we did the other lesson. The only difference is that it's now equation-based, so we're not using the boxes really, we're using the symbols themselves. The reason why I saved the distributive property for 9, 10, 11 is if you look at 9, 10, 11, they only have one mixed number and one whole number. One whole number, one mixed number. One whole number, one mixed number. So for 9, 10, and 11, there's a whole number element to it. Whereas from 1 through 8, they're all mixed numbers, or fractions at the very least. So let's look at the distributive property for number 9. 4 and 2/5 times 10. If we're to think about the area model to help us visualize this equation, we would be looking at 4 and 2/5 split over here, and then we'd be adding them, right? So 4 and 2/5. 4 and 2/5 is the same as 4 plus 2/5. It's 4 plus 2/5. The 10 over here is itself, and there's no fraction, so you don't need to put the second line in a fraction here. Since there's no fraction, you only have 2 boxes. Because you only have 2 boxes, guess how many numbers we're going to have to add? Only 2. 1, 2. So times 10. Look at how this is very different from this one. Because here we had a whole number and a fraction, a whole number and a fraction. We had 1, 2, 3, 4 boxes. We had 1, 2, 3, 4 equations to solve. This one's pretty cool. This one is the 4 and the 2/5, then the 10. 1, 2 numbers. The first one we're going to do is 4 times 10. 4 times 10. 4 times 10. The second one we're going to do is 2/5 times 10. 2/5 times 10. Now, if they had a second fraction here, then yes, we would have had more equations to solve, but there's only 2 here. What are we going to do to these 2 answers? Well, what do we do when we solve these 2 answers? We add them. So in between this, we're going to put an addition sign. All we have to do is solve. 4 times 10 is 40, plus 2/5 times 10. 2/5 times 10 you could do 2 ways. You could do 2/5 times 10 over 1 and multiply the tops and the bottoms. 2 times 10 is 20. Oops, equal sign. And 5 times 1 is 5. Then the numerator is bigger than the denominator, so it goes inside the house. 20 divided by 5 is exactly 4 with no leftovers. So your final answer is 4. So 2/5 times 10 is 4. A second way you could have done that is 2/5 times 10 over 1 and simplified ahead of time. 10 divided by 5 is 2, and 5 divided by 5 is 1. 2 times 2 is 4. 1 times 1 is 1. Either way, 2/5 times 10 is going to be 4. 40 plus 4 is 44, and so that is your final answer. 4 2/5 times 10 is 44. The way you did that was you broke the 4 2/5 out, 4 plus 2/5, and the 10 stayed the same. Then you multiplied this number by that, and that number by that. I'm going to get you started with the next problem, but I'm not going to solve it for you. So all I'm going to do is get you started. For number 10 is 26 times 2.5. And so checking I wrote it right. And I'm just going to help you write it out. The first number goes up and down, so it's 26. And we're not going to put a second one here, or we're not going to split it because there's no fraction. And here there's a fraction. You're going to split it for 2 1/2. 2 1/2. So 26 is going to stay the same. And 2 1/2 is going to be the one that breaks up this time to 2 plus 1/2. Look at how it doesn't matter which way the extra one goes. Either way, you're taking the first one on the left side and you're multiplying by the right until there's no more numbers to multiply. Then you take the second one and you multiply it. Here you're going to take this one and you're going to multiply it. You're going to take the 26 and you're going to multiply it by the 2. 26 times 2. 26 times 2. Then you're going to take the 26 and you're going to multiply it by the half. You're going to take the 26 and you're going to multiply it by the half. And what do you do when you do the 26 times 2 and the 26 times a half? You add your final two answers, and this final answer will be the final answer. So hopefully this helped start you off. And just like I started you off on here, I'm going to start you off with the next word problem. And then we're going to wrap it up and call it a day in terms of this video, but do make sure to finish the whole assignment. Jake can carry 6 1/4 pounds of wood in from the barn. His father can carry 1 5/7 times as much as Jake. How many pounds can Jake's father carry? So Jake can carry 6 1/4 pounds, and his father can carry 5 7/5 times as much as him. So if all we have to do is change this mathematical equation to, this English write-up of it into a mathematical equation. So how many pounds can Jake's father carry? It says right here, his father can carry 1 5/7 times as much as Jake. So if you're asking for how much Jake's father can carry, and it says here his father can carry this much, all we have to do is change this sentence into a mathematical equation and we're done. Here they give us the first number, 1 5/7. Times as much as means multiply. So it's 1 5/7 times whatever Jake can do. What can Jake do? Jake can carry 6 1/4. So under Jake, put 6 1/4. And when we multiply 1 5/7 times 6 1/4, these two numbers multiplied together will give you the final answer. And you can solve the problem in any method you like. You can solve it using the distributive property, or you could solve it using improper fractions. I hope that these videos were helpful, and let me know if you have any questions.